Hey guys, in this video I'm gonna discuss the solutions of educational code forces round 89. So let's start with problem C. So in problem C we are given a grid consisting of zeros and ones. For example, we are given a grid like this, and in a problem we have to move a item from the starting point to the ending point. Now there is something called palindromic path in this problem. So a palindromic path is that the starting point element should be equal to ending point element, and the second element should be equal to last second element in the path. For example, if I take this path right here, in this path we have this element equals to this element, and this element is equal to itself. So this is a palindromic path. Now what we had to do in the problem was that if we take any path, it should be palindromic. So we have to change some elements in our grid so that every path becomes palindromic no matter what path we choose. So let's see another example. Let's say we have 1 0 1 0 0 and 1 1 1 1 0, and in the last 0 0 1 0 0. So here we have to make all the paths palindromic by changing minimum number of elements. For example, if I take this path should be palindromic. So the first element should be equal to the last element. So here I'll have to make it 1, or I could make it 0, and here I have to make one of these elements equal to 0 or 1. So if I make it 0, and these elements should be equal, so I can make it 0. Now this is a palindromic path because first element equals to last element, second element equals to second last element, and third element equals to third last element, and fourth element equals to fourth last element. So I have to change minimum number of zeros or ones so that all paths become palindromic. So my intuition for this problem was that, let's say I have to see these elements. See this group. This group has a distance of 2 from the starting point. This has a distance of 1, and this group has a distance of 2. This group has a distance of 3. Now what I'll do is I'll see the group with distance of 2 from the starting point, and the group with a distance of 2 from the ending point. Now in this group I can see that this element was 1 initially. So this element was 1. Now I have to change minimum number of elements so that all the distance 2 elements becomes equal. Why I have to make them equal? Because I can take these combinations or these combinations, because we have to consider all the paths. So finally we can see that we have to make all the elements equal, and the possible way to do this is that we can change all the zeros to ones, or we can change all the ones to zeros. So here we can see that if I change this 1 to 0, it will take one operation, and if I change these 3 zeros to ones, it will take 3 operations. So I can see that I'll just change one of these which take minimum number of operations. For example, if I had 3 zeros and 4 ones. Here I will change zeros to ones, and if I had 4 zeros and 3 ones, in this case I'll change 1 to zeros because it takes minimum operation. So this is the solution, guys. We will just check all the distances from the starting point and from the ending point, and we'll just change all the zeros to ones or all the ones to zeros depending on whichever gives me minimum answer. So let's now see how to implement this solution. So to implement this solution, we can take a count array which will have two indexes. This will contain 0 or 1. 0 will give me count of zeros, and this will give me count of ones, and this will give me index I. So totally count of I comma 0 will give me count of zeros at a distance of I, and count of I comma 1 will give me count of ones at a distance of I. So finally I will just calculate this count array, and finally we will have count array starting from one distance to n plus m minus 1, and here for example for the first and the last element, all the elements should be equal. So here I'll have count of 1 comma 0 and count of 1 comma 1, and here I'll have count of n plus m minus 1 comma 0 and count of n plus m minus 1 comma 1. So if I add both of these, I'll have something. Let's say this is count 0 and this is count 1. If I add both of these and both of these, so I have to make one of these equal to 0 or 1. So my answer will be minimum of count of 0 comma count of 1. I have to take minimum of these, so I'll add it to my answer. Similarly we will do it for second and last second, and then we will do it for third and last third, and so on. So this is the solution for problem C. Now let's discuss problem A. So in this problem we are given two integers a and b. A are sticks and b are diamonds. So we can make two items from these sticks or diamonds. If we take two sticks and one diamond, we can make one shovel. While we take one stick and two diamonds, we can make one sword, and both of these are sold for 1 emerald. And in the problem we have to count how many maximum emeralds we can earn. So to do this problem, my intuition was that if A is greater than B, and if it is not greater than b, I'll just swap a and b. If it is not greater than b, so finally I'll have a greater than b, and I can see in the problem that I can make shovel or sword. It doesn't matter if I make more shovel or more swords, because both are sold at a price of 1 emerald. So finally I'll just have a greater than b, and my intuition was that while a is greater than b, I'll just make shovels, and when they are both equal, a equals to b, I'll do something. I don't know, but I'll do something, and while a is greater than b, I'll just make shovels. So until when can I make shovels? So I can see that if I make x shovels, I will have a minus 2x sticks left and b minus x diamonds left, and I can make shovels until sticks are greater than diamond. So I'll just make them equal to calculate x. So x will be a minus b. Now after calculating x, I will subtract 2x from a and x from b. After doing this operation, I will have a equals to b. Now what I have to do is, I'll see it through an example. So let's take a and b equals to 5. So now I can use 2 from 5 here, I'll have 3, and 1 from this to make one item. And now this is greater than 3, so I'll just take 2 from it and 1 from it. So I can see that if I use 3 of both sticks and diamonds, I will make 2 items. So finally what I will do is, initially my answer is x, so now I will add to my answer b by 3 times 2, because 3 of diamonds give me 2 items. As these are both equal, so I can take a by 3 or b by 3. So I have taken b by 3. Now at last I'll just check if b percent 3 is greater than equal to 2. If it is greater than equal to 2, it means that a percent 3 is also greater than equal to 2. And now I can see that I can make one more item, either it is sword or it is shovel. So I can make one more item, so I will add 1 to my answer. So my final answer is x plus b by 3 times 2 plus b percent 3 greater than equal to 2. So this is my final answer. I have taken b here as b minus x. So this is my final answer for the problem A. So now let's discuss problem B. So in the problem B, we are given an array consisting of zeros, and only one element is 1 in this array. For example, if I take this array 1 0 0 0 0, So this is kind of array we are given in the input. Now I am given some queries L to R, and in each query I can choose two indices. For example, if I am given this query 2 to 4, I can choose two indices C and D. Both of these should be between this range, and I'll just swap the elements of these indices. For example, here if I choose this index and let's say this index, I will just swap the elements. And let's say if we were given this range and I choose this index and this index, so I will just swap these elements. Finally I'll have 0 0 0 1 0. So I can do this operation with each query, and finally I have to count the number of indices such that I can make those indices equals to 1 after doing all the operations. For example, let's see the example. So we have 6 4 and 3, and the range are 1 6 2 3 and 5 5. So we have 6 elements in our array and the fourth element is 1. So we have 0 0 0 1 0 and 0, and I have 3 queries. So in the first query I am given this range, so I can choose any two indices and swap them. So if I choose these two indices, I'll just swap them. So I'll have 1 0 0 0 0 0. So I can see that I can make my first index equal to 1. Similarly, if I had chosen this and this index, I can see that I can also make index 2 equals to 1. So here also can come 1 and here also can come 1 in this example. Because the range is 1 to 6, I can choose any of the index so that that index can become 1, and I had to count these number of indexes. So in this problem my answer will be 6. Now let's say let's see another example. Let's say we are given these queries 1 2 2 and 1 2 3. So here in the first query I can choose the first and second index, and then I can make this equals to 1. And if I had chosen only this index, I can make also this equals to 1. And for the third query I can see that I can choose this index and this index, so I can make it equal to 1. So I can make all these 3 indices equals to 1, and so our answer will be 3, because I can make all these equal to 1 with some number of operations. So how to solve this problem? So my thinking was that I will just find the range up to which I can make the index equal to 1. So I'll just maintain two variables, x minimum and x maximum. Initially x minimum will be equal to x only and x maximum will be equal to x, and in each query we are given L to R. So I will just check if x minimum is within this range, then I will update x minimum equal to L. Similarly for x maximum, if x maximum is within this range, I will update x maximum equals to R. Finally, I'll have some x maximum and x minimum. So my answer will be that this whole range, let's say I have x minimum here and x maximum here. So I can make all the elements within this range equal to 1. So my final answer will be x maximum minus x minimum plus 1. So this will be my final answer. So this was the solution for problem B. Now let's discuss problem D. So in problem D, we are given array A1, A2 and An, and in the problem for each element we have to find two divisors D1 and D2. These both should be greater than 1, and also we have to find such divisors such that GCD of D1 plus D2, comma, for example if I am considering the second element, comma A2 equals to 1. So how can we solve this problem? Now we can see that D1 and D2 both should be coprime. So their GCD should be equal to 1. Because if the GCD of D1 and D2 is not equal to 1, then it means that it has some divisor D, for example, and this divisor will also divide A2. So my final answer will be GCD of D comma A2 is equals to D, which is not equal to 1. So I can't take D1 and D2 such that they are not coprime. So my final solution is that I'll take any of the two divisors of AI such that both are coprime to each other. So how can I solve this problem? So in the problem we are given a constraint of that AI is less than equal to 10 raised to power 7 and greater than equal to where is problem D? So problem D has AI is greater than equal to 2. So this was the limit for AI. So what I can do is I can find all the primes up to 10 raised to power 7, and the number of primes I'll find is up to 400. So now what I'll do is for each element AI I will just I'll check something for each of the primes. For example, if I am checking for prime P, what I'll do is I will check if AI is divisible by P. Then I will take two variables, temp1 and temp2. So temp1 initially will be equals to 1 and temp2 will be initially equal to AI. And what I will do is while temp2 is divisible by P, I will divide it by P and I will make my temp1 multiplied by p. Now finally what I'll check is, after coming out of this while loop, I will check temp2. If temp2 is equals to 1, then it means that this prime is not suitable for my answer, because then ai will be something like p raised to power k, and my answer will be just -1. And if temp2 is not equal to 1, then it means that ai consists of some p1 raised to power k1 and p2 raised to power k2, at least two prime numbers. So ai consists of at least two distinct prime numbers. So both of these are co-primes here. So when temp2 is not equal to 1, our temp2 will be equal to our answer will be temp1 and temp2, and actually these are equal to p1 raised to power k1 and p2 raised to power k2 and multiplied with something, if there are more primes in ai. So this will be my solution for fourth problem, and the complexity of this will be like the number of primes are 400, and number of elements in the array was 5 into 10 raised to power 5, so it becomes 5 into 10 raised to power 7 something 20, so it becomes 2 times 10 raised to power 8. It will pass the time limits, and so this is our solution for the fourth problem. So that's it for this video guys. Thank you for watching.